Welcome to our webinar to create your own module for the Module Application Creator. In this series, we would like to introduce you to your own equipment module within the Modular Application Creator. We will show all the steps necessary to create all the elements that are required. And in the end, you will get a functioning equipment module, which you then can use in the Modular Application Creator. So in the first step, we would like to show you the prerequisites and the programs that you will need for this. And right now, first of all, why should we create your own module? And the answer is quite easy. Probably you have a technical problem that you want to find a solution for, and maybe you have used other modules of the Modular Application Creator before. Maybe you have some experience, and you find that you want to implement your own technology into it. You want to get your own module, which you then can find here in this overview. And in this episode, we will introduce you to the first steps on getting along that way. So in order to create your own module, you need some programs installed on your device. So first of all, the Modular Application Creator modules are being created in the programming language C#. For this, we would recommend Visual Studio. So Visual Studio of the version 2019 or also 2022 would be definitely required. Also, you need to have the Mac Module Builder installed. The Mac Module Builder comes in a V6 file, as you can see here. That's a Visual Studio extension file. This installs all the necessary tools that you need for your module. And you also need to have the Modular Application Creator itself installed. So in the first step, we would need to install this Visual Studio extension. So basically, you just have to press on it, and then the installer will start. You do not have to set up anything, just have to confirm, and then it shouldn't take that much. So it asks you to change something on Visual Studio, and you basically just press install. Take note that depending on your Visual Studio version, you might need a specific V6 data. For example, here you have the 2019, which is for Visual Studio 2019. If you're using Visual Studio 2022, then there's a separate V6 file that you can find at the same destination where you downloaded this file. The Mac Module Builder is available on the CEOS page. There you can always find the latest version. So after our installation is complete, we just close this window. And now we can basically get started with it. So now we started Visual Studio. We installed our V6, our extension for the Mac Module Builder. And now we want to create a new project. So basically we select the new project option. And now, and this is very important, what you need to do is to select the Modular Application Creator Equipment module. This is a new template that's only available when you install the V6 file, like I was showing before. And now if you press next, then you can easily create a new project. Just select the name, for example, getting started. Select the location of your choice, and then you are basically ready to go. Press the create button, and the Mac Module Builder will create a project with a lot of files that you will need, but don't be overwhelmed. You do not need to set up every file, and you don't need to know what's happening in every file. So as you can see on the left side, you have this project tree, and In comparison to a normal empty Visual Studio project, now you can see that you've got a couple of folders that are already filled with files. I want to just explain them very briefly. You've got a help files folder. This is basically for the online help feature of your equipment module. We will get to that topic later. So for now, we can easily ignore it as we are not focusing on the online help right now. So we basically just close it and don't look at it for now. Then you have the model class. Here you've got the model folder. You got two classes here, which is the base getting started EM and the getting started EM. It contains already a lot of logic for the program to run. And the base getting started EM is containing a lot of internal code. So this can be altered for, let's say, advanced functions. But for now, for this tutorial, we will not bother looking at it. So right now, we will also ignore this class. We keep going to the getting started EM. This, on the opposite, is very important. This is kind of our starting class, our manager class for the module. And this is your first starting point when creating a new module. So you can also see that here is a lot of generated code. It also has some comments that basically say it's wise to maybe not change some parts of it. And also gives you hints when you can add or where you should add certain functions. So here there's also some pre-functions created. You have the constructor, for example, here. You got a generate tier portal function that we need later on when we generate code for the tier portal. And it has a lot of space for you to add extra code. So as I said, this is very important and we will start working with it very soon. Next folder is the resources folder. This contains the language keys for translation into German and English. We will learn about the usage of language keys later on. Just for now, you can kind of see this as a dictionary where you can set up an language key, and here you define the translation in English and in German. We also do not need this for now. We will need it later. Then we have the tier imports. This will contain a lot of information about the generation. We will come to that part once we get into the generation process. Then there's the tier resources folder. This is currently containing the Siemens engineering DLL. This is basically the interface for the openness, the tier openness functions. The Mac already includes this, and this module builder also installs it directly. It's important to have, but you do not need to look at it. It's just good to have it there. And then there's the UI. This will contain all the views that we will create that we then show in the UI of your module. This is also part of a lesson later on. Right now, we will also not focus on this, but it will be important in the future. There's one more file that's important. This is the TRS file. This also contains parts of the generation. This will also be important in the future, but yeah, right now also you can ignore it for now. And the new spec and the config file are also not important for you right now. It's important to have them here, but it's not important for you to do anything about that. The module that we would like to create consists of the technology for a so-called flying saw. You can see here how this module is supposed to look from the UI. This is our goal for the UI. And also when we generate a tier portal from this module, we would have like a certain content. We would like to see some function blocks generated and technological objects and libraries created. We get into more detail in the generation chapter. What is interesting for us now is to create the data model and also all the required functions based on our requirements. Therefore, we have to understand the requirements. And here, as I said, we want to create a flying saw. This is our, let's say, main focus object here. So we will need to create a software model for this, and we need to have a look at what are the required properties of this. So as we can see here, we have a material which has two options to select from. We have a material thickness also with two options to select from. And you can see that you have two subcomponents. One is the infeed axis or just feed axis. The other one is the cutting axis. Both of them come with their own properties. You can see they also have a property such as name. Here you can connect the drive. You can see you can select the drive that's already engineered in your TIA portal project. And you have here the property maximum velocity or maximum cutting position. So in the first step, we would just like to create the data model for this. So we can see all the properties that we need here. We come to the point where we generate these properties into the TIA portal later. So do not bother with that right now. At this point, it's important for you to have the requirements, that you know what are your properties that you want to create in the software model. And the software model we basically are going to use later for the generation of the TIA portal project. So all the values that we need, all the inputs that the user needs to do, we already need to have them defined in the software model. So it's important to know these parts. And yeah, as I said here, our goal is to create a flying saw object, and it has some sub objects of the feed axis, the cutting axis, and some parameters with either a value that you can just manually type in, or for example here where you have just a range of values that you can select from. And also in the final program, we would like to be able to not only create one flying saw, but we would like to create many. So for example, if we press that button, I want to create another flying saw. I want to create as many flying saws as we like, or maybe we can also limit the number. But the important part is we don't only want to create one, we want to create a module that's able to have many flying saws in there. So let's start programming. We would like to create now the data structure for the module. We will do this with the software pattern MVVM. It's called Model View View Model. It's quite a common pattern in software development, and it basically distincts your data objects into three parts. There's one, the model or the data model, which will contain the data, basically all the properties that you need in your class. You have the view model, which is there to interact with the model, also has some inside logic. And you have the view. The view is basically the UI. It contains all the required controls, all the ways for the user input. And the view basically uses the view model to access and change data. But the view model can also be used for internal changes of the data. So what we will do is we will create a new folder in our project for that. We will name the folder MVVM. And within that folder, we will create new subfolders. One for the data model, and one for the view model. So the models that we want to create are basically all the models that we need for the definition of our flying saw, including both the feed axis and the cutting axis. So we can see from the structure that we have kind of a parent component, which is the flying saw component, and we have subcomponents such as the feed axis or the cutting axis. The parent component, the flying saw component, has some properties, but also the subcomponents do have their own properties. And therefore, what we will do is we start with the subcomponents and then use them to create the parent component. And as we can see, both subcomponents, for example, have something in common. They both have a name, in this case, infeed axis or cutting axis, and they can all be connected to a drive. Basically, this drive connection is for later creation of technological objects and to connect them to an existing drive. So we also need to provide a possibility to create a technological object and, of course, adding a drive to the technological object. So we can see that both subcomponents, both axes have some parts in common, but also some parts are different. Like the maximum velocity only exists on the feed axis. The cutting axis therefore has the maximum cutting precision. So we take this into account, and given that we're smart programmers, we will create a base class that will combine all the parts that are that exist in both axes. So therefore, we create a base class for that. I will call that model an axis base model. You can give it your own name. Just make sure that you keep in mind what it is. So here I've got this axis base model class. And what I do is I make it public because I need to use it from other parts of the program. Also, I want to make it abstract. Abstract means you cannot create an object of this class, but you can create an object of the derived classes from this. Because the space model isn't a class that we want to create, but we want to derive from it. And yeah, that's why we make it abstract. And as I said, the parts that both classes have in common is first of all the name, and then also the technological object. So we will include both of them parts. And here you can see if you add the technological object, we have a class called technological object info. This is a class provided by the modular application creator. And you can get access to this class or can get it recognized if you, for example, right-click on it and get to the quick actions and refactoring. And here it's already suggesting you as a first option to use that namespace. This is a namespace that comes from the Mac core, and it includes this class technological object info. And this is a software representation of our technological object. So we only need to implement this class, and this will help us a lot in generating the technological object. Later, we get into more detail about this once we get to the real generation into TR portal. For now, we only need to define it, give it, let's say, some good values, and yeah, therefore, we also need some more inputs for that. For example, each technological object requires a motion control version. And also an important part is to add a telegram number. This will be required for the connection to the drive. So we add the motion control version 6.0. This is the current version in TR portal v17. And our main telegram number, we set it to 105. You can also set it to a different one depending on your requirements. For us, we just decided for 105. It will help us go with it. So also what we can add is maybe some comment to explain what this class does. So here, for example, could add something like that. So here we have our axis base model class. It's nice and simple and contains all the parts that are shared by the infeed axis and the cutting axis. In the next step, we are going to implement the infeed axis class. So this is another class of our data model. I will call it infeed axis. You can also call it infeed axis model. And For this class, we basically will define first of all that it's deriving from our base axis base model. Already get that suggestion. I'm gonna make it public too. And what we add here is one more information about the technological object, because one thing we need is technological object type. So it's something like a positioning axis or a speed axis. In our case, the infeed axis is a positioning axis. The modular application creator has therefore already a constant, which it needs to define the technological object type. And here, as you can see, if you right-click on it, use the quick actions and refactoring tab, you get also the option to use the namespace that is required for it, and then it will recognize this openness constants class. And another thing, as we've seen, we want to have here the maximum velocity. So this is a property that we need to define here, and we make it a string, call it maximum velocity, and give it a default value of 100. Also, we are going to add some nice comments, so we get some more information about that class, and then we're done. This is all we need for our infeed axis, and in the next step, we will do similar actions for the cutting axis. I will name that class cutting axis again, like similar to before. Make it public and let it derive from the axis base model class. So here we also got the technological object type as before. In this case, we will have a synchronous axis, and we also have a new property, which is the maximum cutting position. So we will add both of those. Again, here it doesn't recognize the openness constants class. Get that done by using the right namespace. So here, as I said, we have the synchronous axis. I think that's easy to spot. And now we're basically done. This is our model for the cutting axis. We were defining the infeed axis before. Now what we also do is adding a nice comment. And yeah, that's basically done. So before we are able to create the flying axis model, we need to create the view models in advance, just the classes. This is because we will need to access those classes within the flying saw. I will show you why. First, let's just create those classes. All the ones that we need for the view models are first of all the axis base view model class. So we basically create a view model for all the classes that we created so far, including the flying axis, flying saw view model. So now we have the axis base view model. Next thing we do is the cutting axis view model. Again, we will make all of those public. The infeed axis view model. And now I will also create the flying saw view model, even though we don't have the flying saw model yet, but we will create it soon, and yeah, it's not a problem to already have that class. So now we created all the classes for our view models. And why is that important to have them already now? It's basically to make it easier for us to create a flying saw model. So what we do is that we create here in the data model a new item. I will call it flying saw. You can as well call it flying saw model. Either way is totally fine. For me, I will call it flying saw. And what I need in this class is basically some properties, like, for example, a name. Of course, the flying saw contains of a cutting axis and an infeed axis, so those parts are required. But also, as we've seen before, we will need a material type and a material thickness. So in the first step, I would actually define the material type and the material thickness. I will define them as an enum. That means we have only a selected amount of values that we can set for this data type. So here you can see it's a data type of itself, material type, and you have these both options, steel sheet, aluminum pipe. You can name those ones as you like. For me, I find these names to be quite fitting, but go with whatever suits you. And we do the same for the material thickness. We get two options, a thickness of small, which is like 1 to 5 millimeters, and 5 to 10. And now we can add those properties to our flying saw class. So as I said, we need a name, we need cutting infeed axis, material type, and material thickness. So this is what we are going to have. And here, that's why I said we need to create those classes beforehand. What we'll do is we will not give it a property of the cutting axis class, like not the model, but we will use the view model. This is because all the properties of the axis, we want to access them via the view model. This gives us some benefits that will be more clear when it comes to the UI. But also it helps us in managing the model itself, because the view model oftentimes contains some extra functions, some inside logic that could be important. For example, when setting the name of the flying saw, and maybe we want to change the name of the corresponding cutting axis, because maybe the name of the flying saw should be part of the name of the cutting axis, for example, or should just be a prefix. So oftentimes you have some inside logic, so therefore it makes sense to always access those objects with the view model directly and not with the model itself, because then you can make sure that all these inside logic is also being considered and called. So I will also add some little comment about this. And then we are already done with the flying saw class. So now what we have is we got all our models. We get the infeed axis, the flying saw, the cutting axis, and of course the axis base model as a base class for the cutting axis and the infeed axis. So in the next step, we will create the view models. So for the view models, I will start with the axis base view model. Similar to our axis base model, this will be the base for the view models for the cutting axis and the infeed axis. This is because they share a lot of common properties and common inside logic. So what we will do, first of all, is say we need a model. Like every view model needs, of course, a data model. So we will include that as a property. And it's one of our only properties in the view model. Normally, the idea is that a view model should not have these properties at all. It should basically only access the properties from the data model, obviously, but therefore, I mean, of course, it needs to save the data model in the first place. Otherwise, it cannot access it. So here we set the reference to the access base model class. We add this function for the serialization. Here, one thing that becomes important is the thing that you've seen here is a JSON property attribute. It's part of the Newtons of JSON library. This is a library that's being used within the modular application creator to save and load existing projects. And in each class, we need to define which of the properties we want to save. or which one we might want to ignore. I will get to that point later on with more detail. For now, it can be important for you to know that each property that you want to be loaded when you load an existing project could need that JSON property. But there are special rules applying. For example, if you have a public field like the ones that we use in our data model, they will already be considered for the JSON serialization. So they will automatically be saved. So you do not need to add the attribute like I did here, the JSON property. This only applies for protected or private properties or fields that would normally not be serialized. Serialization basically means saving in this context. And the opposite, the loading of data, would be the deserialization. So here with this JSON property, we can say this field that we have here, the model field, this is supposed to be serialized. And this then will be stored in the information. And whenever you open a new project, then this part will be loaded. The next part that we need is, of course, each base view model is part of a flying saw. So it has kind of a parent, as I would call it, and it would also need the reference to that parent. So I will add it maybe above here to make sure that this is like the upper parent, but the order really doesn't matter much. So here we have a reference to the parent view model. This would be the flying saw that contains the axis that we are creating. And now we get to the point where we are going to access the properties of our model. So what we do for that is normally in our modules, in the modules for the modular application creator, we create such a getter and a setter for those properties. So basically, this has to be done for each property that is part of the model. So here in the data model, we have all those properties, technological object and name, and we need to access them via a getter and a setter in the access-based view model. And those getter and setters, they basically look always the same. So as you can see here, the return is normally always directly the data model dot property. And when you set them, it's quite beneficial to test first if the value is even different. If there's no difference in the actual value, then maybe it makes sense to not even go into this routine. So that's why I prefer to check first if the value is there. And then I do all the necessary steps. The first step obviously is setting the property within the data model to the new value. But what can be important is that maybe you want to have some changes that might be done when, for example, setting the name. And in my case, I already prepared a on name change function. I will implement those functions later. Just for now, I want to show that here we have some extra function to do. What that function is, we come to that later. I will first keep on with implementing the other properties. So one thing that we will need in the future, so I will already create that property, will be the called name with prefix. This is going to be the name of the technological object that we are creating. So what we need is that we want to create a technological object in our UI. We already want to select a drive to it, as you have seen before. So we need to have something for the technological object, and the technological object obviously needs a name. And we want to have unique names for the technological objects because TIA Portal will only allow unique names. And we make sure that they are unique by giving it this name with prefix, which basically consists of the parent name plus a dot plus the name of this axis. So for example, you might have something, some technological object in your resulting tier project, which would be called flying saw dot cutting axis or flying saw underscore 2 dot cutting axis. I think that's quite simple to remember. And now, as you can see, our parent component doesn't have a name yet. This is basically because we haven't implemented that part yet. We will get to the implementation of the flying saw view model later on. For now, to not confuse you, I will keep going with the axis base view model. And therefore, in the next step, we obviously need a getter and setter for the technological object. As I said, all the properties from our data model, they will need a getter and a setter. So here I'm creating this getter setter method for my technological object. I have to set the reference to that class, and then that should be working. And again, here, as you can see, the getter is basically just returning the technological object from the data model. And with the setter, I first check if the value is even changed. And if it has changed, then I will set it to the new value. For this one, we don't need any other functions. Just setting the value will be totally fine for us. And so now in the next step, we get to the constructor. And this is going to be a bit more of, let's say, work. So in the first step, of course, we define the constructor. We call it like the name of the function. That is normal convention in C#. What we want to give it to this constructor is, first of all, the parent component, because our view model needs to know the parent component, and we also want to define an access name. So yeah, we want to give it a name of our choice. So we need to add that to our constructor in this case. So what we do first is setting the parent. Obviously that yeah, has to be done. And in the next step, we need to create a model. So here in our model, the case is that we are trying to create a model within the view model. So what we do is, if we want to access or if we want to create a new access, then we will create the view model, and the view model on creation will create us a model within itself. This is basically to have a better structure of the data, because we want our data model to be included in the view model, as I said before, but we also don't want the data model to be accessed from outside. It's quite a way of keeping your code clean to say that the data model is only being accessed by a view model, because the view model knows how to handle all the properties. For example, as I said, like here in the name, we want to have some extra changes that happens when you change the name of the data model. And if you directly write those values into the data model, then this function could not be triggered. So that's one of the main reasons why you always want to use the view model to change the values of the data model, to make sure that, for example, such dependencies that could be like here for the name, that they will also be treated properly. So that's why the model is part of the view model, and it should not be able to access the model from outside the view model. So in the next step, I will create a new model. And here, since this class is an abstract class, I think I haven't declared that yet. So this is good to do now. We are talking about an abstract class. So we will make derivations of this later for cutting axis and infeed axis. And here, because it's an abstract class, we can also define abstract functions, and this will help us a lot later. First of all, I will create a new model, and the model can be a bit different depending on if you're a cutting axis or if you're an infeed axis. So what I will do, I will write a function to create this model, which then can be altered by the child classes of my axis-based view model. So I will call my function create new model. And now, as you can see, I haven't implemented that function yet, but I can just easily do it by letting Visual Studio help me with that. And here it's creating me the new create new model function. So this function is, as I said, it's supposed to be able to change this function later on. And actually, in my case, I'm like, I don't even know what kind of model I want to create here at this point, because basically later I want to create an infeed axis and the cutting axis, and they would have to know how to create a model, but this abstract function actually doesn't really need that. So what I'm doing here is I'm making this function abstract. I'm making it first of all protected, because protected makes me allows me to use that function in the child classes. So I make it protected, and I also define it as abstract. That means I will create this function later. I do not need to create it now, and I'm not even allowed to. But I say this function will be implemented in the child classes. We will see later how that works. It's actually quite easy and helps us a lot this way. And so I say here I have a function to create a new model that will be there once the real object is there. So at this point I will have a model at hand, and this model I will give a name, and the name will be the axis name that I'm giving to getting from my constructor. So now I've set a parent for my view model. I'm setting the model for my view model. And what is left is to define the technological object. We have that property so far in our model, but we haven't started implementing it yet. Like there's no actual model. Like right now, the value for technological object would be null. And of course, that's not what we want. So what we do is also here to create a technological object. So we can use that property that we defined up here, which basically gives us access to the data model's technological object, and we just define it as a new one. And here we can use the functions of the modular application creator to create this new technological object info. This is the class that is being used within a module for the modular application creator to describe technological objects. So here this is basically only a software object, so this is nothing yet in the TIA portal, but this will be used later to generate a real technological object within the TIA portal. And what we need to define here is first of all a name, and this is where our name with prefix comes in. So we use that here. We want to have the name with prefix, as I defined before. Then we have a technological object type. These types can be, for example, positioning axis, speed axis, or any other technological object type. And since we do not know it here, because our cutting axis, now infeed axis, will be both different types of technological object, we also use an abstract method to get this technological object type. So what I'm doing here is I'm creating another abstract function. I call it getTOtype. I can just generate that method. Visual Studio would do that again for me. And here again, like with the create new model, I make it abstract. So I will just copy that part, can remove this function block. And now I've got an abstract function that gives me a string for which defines the TO type. I will show you later which kind of strings we will use for that. We will see that in the cutting axis and in the infeed axis. And also we need the motion control version. We already defined this as a constant in the axis base model. So here I will just use that constant. I can use that from this axis base model class, and here get me that motion control version. And the last parameter we can just leave empty. With this, we're already done. Oh no, one missing. The parent device is missing. At this point, we don't need that. We have to make sure that the parent device is being set up before generating. But at this point, we're not interested in this. We get to the generation after we're done setting all our data. But at this point, we do not need any knowledge about the PLC device. And also we can set a main telegram number. We already have that as a constant. So here we can just say, oh, main telegram number is going to be axis base model dot main telegram number. As I said, we've set it as a constant. And if we look into this, it's set with 105. And you can, of course, select whichever telegram fits your needs. So here we're done with the initialization of the technological object. And one more thing that we need to do in order to work with technological objects, and this is very crucial for generation later on, is that we are adding it to the provided technological objects list from our module. Our module, as I said, is basically defined as this, here in this case, getting started EM class. And this has already a lot of properties in itself. And one of the properties is the provided technological objects property. That's basically a list which just contains all the technological objects that are actually occurring within that module. And it's very crucial to add to that list. So whenever we create a new technological object that we want to use for generation, we have to make sure to add it to that list. This is, as I said, very crucial. And for that, we need, first of all, access to that module class. And in my case, I will provide that access via the parent. So the parent is a flying saw view model. And I will make sure that this flying saw view model has access to the module. For now, just to get us going with it, I will actually just write an arbitrary function for it, which gives us the return type, so we don't have any errors. We will implement that part later on in more detail. For now, I just want to make sure that our code doesn't show errors and that maybe you don't get confused by this. So here I'm having a function that's basically called get equipment module. And for that, I also need a property for that equipment module that I will also add at this point. So here we have the getting started EM. That's the class of our module, like the base class of our module, the central class. And again, we have this JSON property because we want to later on save this property. So here I'm just adding it so we can use it in the access-based view model. So going back to the access-based view model, now we can use the function I just implemented and say parent dot get equipment module dot provided technological objects dot add. And here we say I can basically just say technological object. So this way we added to our provided technological objects list. And this also leads us to another point, which is very important, is that if we want to, let's say for any reason, delete this access, for example, because the parent flying saw might be deleted. We've seen in the UI that we can add and remove flying saws. So we need some logic that would happen when, for example, a flying saw is deleted, because when a flying saw is deleted, also all of the axes will be deleted. So we need to have some kind of routine that then makes sure that these parts are actually being taken care of. And for that, I like to use so-called teardown methods. A teardown basically means to break down this object and make sure that all the required functions are being called for that. So here we'll just add this teardown function. It can be called from the outside. We will see later we will call it from our flying saw parent object. And the teardown at this point will contain basically the removal of the technological object from this provided technological objects list. You can either access directly from the model, or we can also use the property that we defined before. Doesn't make a difference. And one thing that we need to also implement as a function is that we need to make sure that our technological object has a valid name. So first of all, whenever we change a name, for example, we change the name of our of our axis, then of course the name of our technological object has to change. Because as we said, we have this name with prefix, and the name with prefix also, changes when the name of this axis changes. I think this is obvious. But another thing we have to take into account is the TIA portal doesn't allow um, technological objects with the same name. So this is something we really need to make sure that we have unique names for our technological objects. And in order to get a unique name for your technological objects, there we can make use of our provided technological objects list, because this list contains all the technological objects that exist, and therefore it can basically tell us yeah, if a name is unique or not. So what I will do next is I will implement some functions into our module class, which give us the possibility to get unique names for our technological objects. So I will do it in within two functions. I will show you why. Because the first function I need is going to be a function that basically only gets me a unique name based from a list of existing names. This is a very basic function, as I said, to that would just work in general with, let's say, lists of strings, because we will need this logic in two different ways. I will implement this function here. I will just adding it to my getting started base class. And here you can see this function is called getUniqueName. It gets an enumerable. It's basically like a list or some kind of collection that contains strings with all the existing names. And what it does is that you basically give it a proposed name. That's the name that you would like to have. And this function is checking if this proposed name already exists within that list. And if it does, then it will add some underscore and numbers from 0 to 9. In this case, even two-digit numbers. So it would start with 00 or 01, and 02 up to 99, and basically count up until it finds a valid name that's possible. So for example, if your proposed name is, I don't know, infeed_access, but there's already infeed_access existing, then it would give you back the name infeed_access_1. And if there's already an infeed_access_1 there, it would give you back infeed_access_2. Or in our case, as I said, we have a two-digit, so it would be _01. Or if _01 is already taken, it would give back _02, and so on. Maybe we have to add some references, for example, to link. System.link is a very useful tool for example, here, checking lists if they, for example, in my case, contain a certain value. Here in this case, I'm asking, does it contain this proposed name? Then everything's fine. Return the proposed name. It's valid. No problem. If this list does contain the name, then we go into the else. And if it contains the name, then it means the name is already taken, and it should add this number until the name is unique. So it basically always tests with the added number if the name is unique, and if it's not, it takes another round in this do while circle until it finds a valid name. I think this is not so difficult, and it will help us to get an actually unique technological object name. And this is what we implement in the next step. So here we have a function, I will call it getUniqueTOName. It will basically also accept a proposed name as a string. This is, of course, the name that we would like to give our technological object to. And also here I've added an optional parameter of the target technological object info. This is basically there that if you have an technological object that already exists, then this technological object would be part of that provided technological objects list that I was defining before. So if it's already part of this list, then of course its own name would be part of a list of existing names, but its own name would change in the process. I mean, you want to give it a new name, so its own name that it already has should not be considered as an invalid name. So basically what it does here is that if I am having a target TO info that I'm giving, if I'm telling that the technological object already exists that I want to set the name to, then here it's removing this target technological info from the list of possible names. So we say the name of this technological info is not part of the current TO names or of the existing names, because we say this is, since we are going to change it, we can use that name as a valid name. So here it's then saying that I take all the technological objects from the list, I select all the names from it, and then I start my function that I was defining before to get unique name with all the existing names, the proposed name, and then I get as a return a valid technological object name. So this function in the end can be called through the module base class, and it will be able to give us a proper technological object name that is unique within that module. And this is very important. So now I will go back to my access base view model, and what I can do now is I can write myself a function to automatically update the name of my technological object. That takes everything into account that I was explaining. And this function I will call update name of technological object. I'm adding it here. And as you can see, there's the, like, first of all, of course, the function with the name. The new TO name, first of all, is the name with prefix. That's the one that, from the property, as I said. That's just the name that we propose for our technological objects. But then we say, okay, now the module should make sure that we get a unique name with this. So maybe this name is already taken, and then as a result, we might get the name with _1. This makes sure we always have a unique name for our technological object. And this is very crucial because otherwise you cannot generate technological objects, because TR Portal will just forbid you to even create a technological object with the same name. So it's very crucial to keep those names unique if you want to generate technological objects. So yeah, this function is basically there to help us keeping that name unique and keeping it up to date based on the name of our axis, but also based on the name of our flying saw. So what we do in the next step is then that we say, okay, we need to first of all react on a name change within our axis base view model. And this is where that part comes into play that I was describing before, or that I mentioned before. We had this on name changed class. So this on name change class is not implemented yet, but I will just add it very briefly. This function should be added. You can add it wherever you want. I prefer to add it on the rather lower part of the code. And it's, basically just calling the update name of technological object function. So this, whenever we change the name, this function is called, and it makes sure that our technological object name is going to be unique. And this is, as I said, very helpful, very important. One thing now that we still need is that we have also the case that our flying saw parent component can change its name. And this would also lead to a change in the name with prefix, which then leads to a change in the name of the technological object. And so how do we do that? We need to know basically when the parent component changes its name. And from here, from our access base class, we don't know this yet. So what we do is we implement an event handler for our flying saw. An event handler, I think you should be familiar with the idea what event handler is. It's basically to notify other parts of the code, for example, of changes that you do in your class. I will implement that here. This is something that's not specific to the modular application creator, so you can find huge amounts of information about this in all the normal home pages, for example, and all tutorials regarding such topics. So don't be shy to try that out. So here we have a property changed event handler. This basically just notifies that a property has changed. And what we have to give it is that we say we have to define the name of, or we have to give it the name of the property that changed. In this case, it's our name property. And as you can see, we haven't implemented that yet. So I will also implement it right now. And it's literally the same as we did before in the access base view model. It's a getter and setter to access the model's name, and really nothing more than that. And what we will do then is to also add the model as a property, because otherwise then we will get this error here again. So I will add the model here up here. It's a flying saw, as we mentioned before. So now we already implemented half of our flying saw view model on the side, but this is just required. Otherwise, we would have errors in the access-based view model class. But I think so far it's quite easy to follow all the steps we did for the flying saw view model. So we have property for equipment module, property for the model. So far we have a getter setter for the name from the model, get equipment module function to return the equipment module. And here now we have this event handler. So this is supposed to notify us whenever we have a change in the name of the flying saw. And we will not only need this for the access-based view model, but we will need it later on also in our for our UI validation. We'll get to that point once we get to the UI lesson. But yeah, it will be an important part later on. So now what we can, or what we have to do is that we here in this class, in order to make this event handler work, we need to call this function, this raise name changed. This raise name change is a function, as you might see. It's calling this event handler with invoke. That means to call it. And every function that is connected to the event handler, we will connect functions to it in the next step. But every function that is connected to it will then be called and will be given these arguments. So it basically knows with this, it knows where it's coming from. It knows it's coming from this flying saw. And here with these event args, it will know that the property in question is the name property. But this function needs to be called. And obviously, in the same way as we have done in our access-based view model, we call it whenever the name is changed. And here you can maybe see what is the benefit of having this this calculation before to see if the name actually changed. Because if the name did not change, if somebody, for example, sets the name to the already existing value, then you would trigger all these functions. You would call this raise name changed. And this would then trigger within, for example, the access base view model class, the changes to the technological object. And I think that wouldn't make sense because in such a case, because of course the name hasn't changed. So why should you change the name of the technological object? But nevertheless, if you are not having this if clause, if you're not testing whether the value actually changed, you would always run into this whole routine and therefore also decrease a little bit your performance because you're running functions that are not even necessary. Here in this case, that effect is probably minor because we are not doing too much of calculations there. But if you have a very complicated module, very complicated equipment module for the modular application creator, that can really cause some delays. So I would always suggest people to use this if clause, test first if the value really changed, and then only then set the value and do all corresponding actions accordingly. So going back to our axis-based view model, which we try to focus on, now we only have to find a way to connect to this event handler. And this is fairly easy. We can connect to it basically by just calling it directly and get something like this. We have this name changed event handler that I was just defining, and we say with the plus equal that we are adding a function to it. This function at this point does not exist, as you can see. What I do, I will create it. And here you get a function that's already containing all the parameters and the types. So if you don't know what kind of types you might need for such a function, this way Visual Studio helps you out quite a lot. And this on parent name change, I can implement easily. It's going to basically just include the function for update name of technological object. So it's basically doing the same as the on name change. But we will still keep different functions because maybe we want to add something to the on name change function which is not part of the on parent name changed. So it's, I would say, quite vital to keep those ones separated. But it makes sense, of course, to put them maybe together so everybody would know that they are doing, or that they're both reacting on changes of properties. Can also add some comments to it. And one thing we need to do for this is that whenever we do a tear down, we should remove such listeners. Like a listener basically is what I call such a function who is connected to an event handler. And these ones, it can be beneficial to delete them on a tear down because you don't want to have some connections to objects in your code. Even if you want to delete those objects, it might be more safe to remove such listeners by hand, like here with the tear down function. It's not necessary. It should also work without, but yeah, just to be sure, um, it can be quite vital to do, especially if you have a lot of such event listeners. Things can get a bit more complicated, and you don't want to have dependencies to parts of your code that might not even exist anymore, that might only exist in the kind of storage, but not part of your program anymore. So now we have already set up the constructors, all the required functions, and we're basically ready to go with this base view model. It's pretty much done at this point. There's nothing more that we need for now. We will extend it a little bit more when we come to the UI and generation topics. But for now, this axis base view model will suit our purpose. Now we need to create the view models for our cutting axis and the infeed axis. This is going to be much more simple than the axis base view model, basically because we have already created most of the things we need in the base view model. So now what we need to do is only adding the parts that are missing. So here, first of all, we define the cutting axis view model as a child of the axis base view model. This is important. We want to use the inheritance function, and therefore, yeah, we need to use it in this way. So we say, yeah, it's inheriting from this class, and now it will tell us already, oh, you're missing some parts. This class is not abstract anymore. As we remember, the axis-based view model is an abstract class. An abstract class is a class that doesn't exist as an instance object. You cannot create an instance from it, but a class that is not abstract can get an instance from, and therefore it needs to implement all the abstract functions. So as you remember, we were creating some abstract functions because we didn't know how they would look on a real object. Like, for example, we didn't know how they looked on a cutting axis. So we said, okay, we'll get a TO type, and the cutting axis will give us that. But right now we do not know. We only know it's a string type, and that's enough for us to work with it. And the same goes for the model. So we know that this cutting axis will define some axis base model that we can then use to work with. But we do not need to know more at this point. But now when we're getting to the cutting axis view model class, then of course we have to implement them, because then it gets important to have those ones defined. So what we can do, we can use Visual Studio again to help us implementing those. So it will create functions for these. And also we need to create a constructor, of course. So let's start with the abstract functions. I think they are fairly easy. The get TO type is basically just to return us the technological object type. It's a string type, and it uses constants from the modular application creator. Here they are called openness constants. They're part of the modular application creator, and Visual Studio can give you the reference to it, and then you can just use it. And for example, here we have the synchronous axis type for the cutting axis. Other types, if you want to have a look, just here you can see that, for example, you have the speed axis, positioning axis, external encoder, kinematics, leading axis proxy is also possible. But we will go with the TO synchronous axis here for the cutting axis. And when it comes to creating a new model, that's also fairly easy. We basically just say, create us a new cutting axis model, or cutting axis in this case, nothing more. It already contains everything we need. Do not need to set anything. So here we can define it like I've written here, and do not need more. Next thing we need to implement is the constructor. The constructor is also fairly simple. We only need to have the same properties that we had before. So here I was creating the cutting axis view model. That's the constructor. It gets the parent flying saw view model and the cutting axis name. And then it's calling the base constructor. So it's calling the constructor of the underlying class, which is the axis base view model. That's the one that we've defined before. It contains everything we need. We do not need to change anything. Thing is only we need to have this constructor, otherwise Visual Studio lets us not compile it because it needs to have a constructor that then would call this base constructor. So this is also fairly easy. And another thing that we need, that we have also done before, is that we need a getter and a setter for the maximum cutting position. We have the maximum cutting position is a unique property in our cutting axis. You can see maximum cutting position. So we also need a way to access it from the view model. Similar to like we did with the name or the technological object before. We need to access it here. And now you can see, oh, the maximum cutting position doesn't exist in our model. Why is that? And the reason is very simple. The model is of a type axis base model. So it's using this axis base model class and not the cutting axis class, which we would like. And this is by concept, this is on purpose like this, because we are using the model from our axis base view model. So we are using this property. And this property, as you can see here, is an axis base model. So what we want to do is that we want to say, okay, our model that we use now is not a base axis anymore. It's a cutting axis now. So what we do is we implement this model as a new way, and therefore I'm creating as a new property with the new keyword. This will override the existing underscore model. And I will define it in a way that I say, okay, in the getter, now it's not returning me only the base model, but it's making a typecast and say the base model will be returned as a cutting axis. So now I can still use my underscore model property, but it will be a cutting axis type. And now you can see the errors are gone. It's recognizing the maximum cutting position property, just like I wanted. Everything's fine. And that's it. That's our class for the cutting axis view model. So as I said, it's fairly simple. We've done all the hard part before in the access-based view model. And of course, as it is always with inheritance in C#, it's this cutting access view model would of course use the functions from the access-based view model. And now I want to do the same for the infeed access view model. So if we go to the infeed access view model, we can see, okay, it's an empty class like we defined, obviously. So now, first of all, we make the same step as before. We make the inheritance the access-based view model. And now it will tell us, oh, we're missing some parts of it. If you hover over it, you can again see what it's missing. And we use Visual Studio to help us with that. And now I can just use the same way as I did before. The create new model function will create a new infeed access in this case. And here the get TO type function is again using the openness constant to, in this case, give me a positioning axis. So here I want to have a positioning axis contrary to what we had in the cutting axis. Therefore, that's why we needed to make it abstract, because now you can see we can implement it here with giving us a positioning axis, while here this function gave us a synchronous axis for the cutting axis. And the same happens with the create new model function. So here in the cutting axis view model, we get a cutting axis back, and in the infeed axis view model, we get an infeed axis back. So yeah, as you can see, that's quite a smart way to implement those parts. And what is still missing for the function to be compilable is, of course, the constructor. So now I will add the constructor. Again, the constructor contains the same properties as the base constructor, contains a parent, flying saw view model, and infeed access name, and passes them on to the base constructor. You can see the default name here is set as infeed access. In the same way, like in the cutting axis, the default name is cutting axis. And what is missing, analog to the cutting axis view model, we need to get access to the maximum velocity property. This is our unique property on the infeed axis. Here you can see maximum velocity. It's a property that we only have here. So we need a getter and a setter for that. And we do it the same way as we did for the cutting axis. So here we have the, we don't need validation yet. The race property changed yet. So we can do that part and we can say, okay, look, we have got a setter for this. It returns us again the property maximum velocity. And here, same procedure as always, set the value only if the value really changed. And here we still have, or we got the same problem as before. The model that we want to access is still of an access base model type. So we do the same kind of typecast as we did before by adding this new implementation of the underscore model property. So here we created that part, and it's basically just typecasting our model to an infeed access type. So now we can use the model as an infeed access type, not as an access base model anymore, and therefore it would recognize the maximum velocity of it. And yeah, that is everything we need to do to get the infeed access view model running. And now in the last step for our view models, we need to create, or we need to finish the flying saw view model. We've seen in the steps before that we already did some implementations for it because we needed that in the other view models. So that's why I'm sorry if that got a bit confusing, but it's unfortunately it's necessary when you have these kind of connections and dependencies. So right now we need to focus on finishing that part. I want to show you what we already have. So our flying saw view model already contains the equipment module class. This is important, as we've seen before, in our case, to get access to the collection of technological objects that are all within the module. This is important because only the equipment module class has access to all the provided technological objects. because it's kind of the manager class of the whole equipment module. So therefore, it has, let's say, the overview over everything that's not specific to only one object. And this way, that's why we need to have an access to it, and we also need to store it. And here, as you can see, we have the JSON property again. And one thing you might notice is we have also the JSON ignore. JSON ignore means to ignore your property for serialization. As I said before, JSON property makes this property to be saved. So it's being serialized, and it will be restored and load when you open an existing module within the modular application creator. And JSON ignore does the opposite. It makes sure that this property is not saved. And this is important because here our name property is basically only accessing the model property. And the model property is already being saved. So there's no use in saving this property. And it can, in fact, even cause some issues when it's, for example, being loaded and then this routine would be called. You normally don't want that. When you're loading data from your existing module, you normally want to load only the very basic data, like not in a way like with a getter and setter where some other functions are called, because unloading that can really cause some issues with the order and with the underlying functions. So it's highly like really would really stress that you are highly advised to only save properties which do not have a getter and a setter. It can be private properties like this one, or it can be public properties like here. But it's important that they don't have a getter and a setter to make sure they don't have any dependent functions that would be caused when setting those properties. Like it's possible to make it work. I'm not saying it's not impossible to also have those functions, those properties stored which have a getter and setter, but it can cause a lot more problems. So the easy way is to just store everything in those properties which do not have a getter and a setter. Therefore, the JSON ignore is a vital function. I will always add it to all the getter and setter that only rely on model fields. So you can see it in the other functions too. Here you can see that, oh no, it's not here. Here would have to be added. JSON ignore. And it should be added to those parts. Here we already have it in the access base view model as a property. And I would also add it for everything that you add in your own code. So now we have the getter and the setter for the name. We have the model, we have the equipment module. We have the function to get the equipment module. I've used this approach to not give a direct access to this equipment module property. Theoretically, it's possible to make this public and therefore also get access to the equipment module via the property directly. But I like it this way better because then from the outside, nobody could change that. Because if you give access to that property from the outside, you could, for example, set it to null, and you don't want that. So this way, it's more of a way to structure your code that only the user can get this equipment module and work it, for example, in the access base units like the cutting axis and the infeed axis. But you do not want anyone from the outside to be able to set that value to something different, because that could cause big problems. And other than that, what we have is the array's name changed. This is the property or the function that will call this event handler, which then triggers functions in the children components, as we have seen before, like in the cutting axis and in the infeed axis. This will be used. It will be accessed via the access-based view model. So here we have the parent name change event handler, and we add some listener function to it. So that was the purpose of the name changed event handler. And the raise name changed function is there to trigger that name changed event handler. So what is missing for us is the access to the material thickness and the material type. We have defined that here as properties. So not only do we have these child components, the cutting axis and the infeed axis, but we also have the material type and the material thickness. And we've done that a couple of times before now. We will add a getter and setter for that. Simple as that. We'll just copy it all in my program and also add the JSON ignore to it. So it just make sure that these ones are not being serialized. And yeah, I will remove the race property changed. We do not need that yet. So this is our getter and setter. I think you're familiar with the structure of that now. So I don't think there's much to explain on that. And now we need to create the constructor for that. So for the constructor, of course, it makes sense to put a equipment module as a parameter. This is important because we want to save the equipment module, as I said before, and it makes sense to give it an initial name. In this case, for example, the default name can be flying saw. And of course, in the next step, then I will add the equipment module as the property. So I will say my property underscore equipment module is equipment module. This way I store the equipment module. And I will need to create a model. So my model is the flying saw. And in this case, I can just say new flying saw. Easy as that. Whenever I'm creating a flying saw view model, I will create a full flying saw. This means I will then also want to create the infeed and the cutting axis within this flying saw. So this is also a step I need to do. So I say infeed axis equals new infeed axis, and I will say I give it an infeed axis view model. Sorry. And this infeed axis view model will require a parent component. The parent component is this function, and it will require an infeed axis name, but I would go with the existing name, so I'm just staying with that. Oh, I'm just currently seeing that the infeed axis is we need properties for accessing the infeed axis and the cutting axis. So sorry, I was forgetting that. Almost forgot it. But yeah, the code will remind you of that. So what we also need next to the name, material thickness, and material type is properties like getter and setter to access infeed axis and cutting axis. So I will add that here. It's, yeah, as I said, simple as that, cutting axis, getter and setter, just basically going to the model again. Same goes for the infeed axis, getter and setter, and how we already know it. And now it already also accepts my infeed axis command where I set a new infeed axis view model. So I'm storing it to this property, which then writes directly to the data model. And I do the same for the cutting axis. I say cutting axis is new cutting axis view model. I give it this flying saw with it. And also I stick with the default name. As you can see here, the current cutting axis name doesn't need to be filled. It will use the default name if I'm not adding anything. And for me, this is very fine at this point. And of course, one thing that's missing is the initial name also has to be set. So I say name is initial name to give a name to my component. And then I'm done with my constructor. One thing I need to know, maybe you've already noticed that I was implementing a teardown function in the axis base view model, which of course needs to be there in the flying saw view model too, because the flying saw is our parent component. The flying saw is the parent that, let's say, it controls what's happening in the underlying components. And when I interacting with this, for example, from my module, like from my module main function directly, I will then interact directly with the flying saw. So for example, I would like to tear down the whole flying saw. So I will need to implement a tear down function for it. And this tear down function is basically only calling the tear downs of the infeed axis and the cutting axis. So far, I have nothing to do in my flying saw in the tear down that is specific to the flying saw other than those both. So that's enough for this point. But it could also be added. Maybe there's something more in the flying saw that might needs to be deleted before you remove that component. And yeah, that's basically everything that you need at this point. For this flying saw view model, we are done now to implement it. It has all the functions that are required. As you can see, whenever we create a new flying saw view model, we will create a new model for it, for the flying saw. And we will create view models for the infeed axis. And as we've seen before, those view models will create their own models for the axis. So what we can do from the outside now is we can create a new flying saw view model and therefore create a model for the flying saw, which has all the important properties. And it will also create for the infeed axis and the cutting axis the view model, as well as within that the models with the correspondent functions and properties. So at this point, we are ready to go and use that flying saw view model in our actually equipment module.